Hi everyone, for today's video, but really I think you can watch these videos in fewer days for this week. Got the last shape that we need to talk about, and this shape is called a hyperbola. So what have we seen so far? Um, set of points, fixed distance from one point, that's a circle. Set of point, fixed distance from a point and a line, parabola. Then we get 2 points and we say the sum constant is an ellipse. And the last one, so it's kind of like an ellipse, except we say that set of points, the difference of whose distance from two fixed points is constant. And these fixed points, like before, they are called foci. So what this says is, if I take this point pxy, the distance from f1 minus the distance to f2 is always a constant. So in some sense it's going to be symmetric, because then the distance from f2 minus distance from f1 is also the same. And that is the shape that we get, which is called a hyperbola. Let's derive the equation. So again, it's going to be very much similar to ellipse. The only difference being, instead of minus or plus, we have a minus here. So let's start with the distance here. So that's going to be square root, again, x plus c squared plus y squared minus square root x minus c squared plus y squared. Once again, we choose 2a, just like I said, as in an ellipse. And then we send one of the square roots to the other side. And then we square. And when we square, x squared plus 2cx plus c squared plus y squared equals x squared minus 2cx plus c squared plus y squared plus 4a squared plus 4a, all of this messy thing again. And just as ellipse, we can cancel stuff. X squared minus x squared is 0, c squared minus c squared, y squared minus y squared. So once again, I take this, I add this 2cx and I subtract this a squared. So I end up with 4cx minus 4a squared is 4a square root of all of this. Again, factor out of 4 and square again. And so cx minus a squared squared is a squared x minus c squared plus y squared. Okay, again, factor all of this out. This is c squared x squared minus 2cx a squared plus a to the 4 equals a squared x squared plus a squared c squared minus 2a squared xc plus a squared y squared. So again, this term cancels out. Let's collect like terms. So send this here. So I have x squared a squared minus c squared let's collect it here. So I get x squared c squared minus a squared c squared equals a squared c squared minus a squared. And once again, divide by c squared minus a squared. So you get, also divide by a squared, yeah, because we want a 1. So you get x squared over a squared minus y squared over c squared minus a squared equals 1, and then you let this be b squared. So instead of plus, you get a minus. So that's why it's related to the ellipse, because just from the definition, instead of the sum being constant, it's the difference that is constant in this case. So it has similar definitions of vertex and foci and stuff. Let's see what that is. The vertex is plus minus a. That's where it cuts the x-axis. There's something called the transverse axis. That's what goes through the focus. We'll talk about asymptotes in a bit. The foci is negative c and positive c, and that's the graph. Now in this graph, there is this blue line, which if you extend your hyperbola, it gets closer and closer, but it never really meets this blue line. And that line is called an asymptote, and there's always two of these for each branch. And that is given by plus minus b over a times x. Now where does that equation come from is, if you solve for y squared, right, you get y squared over b squared is x squared over a squared minus 1. So y squared is b squared times x squared over a squared minus 1. So you take the square root, y is take the LCM and pull out an x squared 2. You're going to get some term here under the square root, and you get a plus minus b over a x. So what that tells you is that the maximum value that y can take is almost equal to whatever this line gives you, multiplied by something which is very close to 1. In the same way, now I switch over the coefficients a squared, b squared. What I get is a hyperbola, but on the other axis. Yeah, so this time that's my asymptote. Now these vertex are 0, negative a, and 0, positive a. And the focus is also on the y-axis now. This is 0, negative c. And the asymptotes switch to being plus minus a over b times x. Now recall here that the relation between a, b and c is that b squared is c squared minus a squared, right? So c squared is a squared plus b squared. So it's slightly different in this case. Let's look at an example. Find all of these things, vertices, foci, length of transverse axis, asymptote for this equation. So first of all, we need a 1 on the other side, so we divide by 144. So I get 9x squared over 144, 16y squared over 144 equals 1. Let's see, the factors of 144 are 42, is that correct? 48, sorry. 3, 16, 2, 8, 2, 4, 2, 2. 2 times 2 times 2 times 2 is 16, and 3 times 3 is 9. Which means 9 goes into 144 16 times, 16 goes into 144 9 times. So that's good. I have a clean looking equation here. So A is greater than B, which means it's shaped like that. So let's see. These are my vertex. A is plus minus 4, B is plus minus 3, the C squared is A squared plus B squared in a hyperbola. So C squared is 16 plus 9, 25. So C is plus minus 5. So I have all the information I need. This vertex is 4, 0, negative 4, 0. Foci is just one away from it, 5, 0, negative 5, 0. This is the length of the transverse axis. Length of transverse axis 2 times A, or 2 times 4 is 8. Asymptote is y equals plus minus b over ax. So plus minus b is 3 over 4x. So the equation of this line is going to be 3 over 4x, and this is going to be negative 3 over 4x. So find the equation of a hyperbola. Now the equation is not given. Vertices plus minus 3, which gives me A is plus minus 3, so A squared is 9. Foci is plus minus 4, so C is plus minus 4, and C squared is 16. So B squared is C squared minus A squared is 16 minus 9, which is 7. So B is plus minus root 7. So A is still larger than B, so the equation is x squared over 9 minus y squared over 7 equals 1. And the rough sketch: negative 3, 0, 3, 0, 4, 0, negative 4, 0, y equals b over ax, asymptote, negative b over ax, asymptote. Oh sure, this video is 13 minutes. We just have one more thing to talk about called conjugate hyperbolas. I'm going to do that in the next video because this has gone too long.